So welcome to the presentation, Data Science with SAP Data, now focus on open source technology. My name is Andreas Forster. I work at SAP Switzerland. I'm a machine learning expert, and I really enjoy sort of machine learning overall, of course, as all of you here in that room are, I suppose, at our conference. That's why we're here. Sometimes it might be difficult to understand machine learning in SAP. How does that fit together? Of course, it's a very broad concept, machine learning overall. SAP is very broad. We have a lot of business data, obviously, in our system that can be super valuable for machine learning, for business processes to be improved. And in that session, I'd like to give a possibly brief overview of how machine learning can be used in open source context in the SAP infrastructure. I brought a few slides along, more or less, hopefully, to set the scene, but I'd like to make it very interactive and also live. So I hope to spend most of the time really in a system where you use open source to connect to SAP to train models out of a very familiar data scientist environment. We are working on a new solution, I should say, up front, where the engines that we have for machine learning, we are consolidating. Data intelligence, you might have read about as well, is the name of the tool, SAP Data Intelligence. And because that functionality is planned to be released later on this month, it means it is not available just yet. Hence, a little reminder that we're very open about the plans that we have, that we speak about it, that we share about it, but plans might change. But we plan to go into customer availability in the next 2 weeks, basically, the middle of June. And setting the scene with our term intelligent enterprise, what we mean by that is really twofold, that we want to make our customers' applications and processes more intelligent by delivering standard content inside our own applications out of the box, as well as allowing our customers to create and implement their own use cases. That means if you're using the ERP system from SAP, latest version called S4, you will have transactions that already out of the box contain machine learning content that you can just use. You can activate models that will be trained on your own individual data. One scenario to mention could be contract consumption. Imagine you've made a contract with one of your suppliers. You can purchase 500 laptops in the next 12 months, and then the system sees how you start ordering these laptops as new people come in, as laptops need to be replaced. And now machine learning can kick in and start, for example, predicting, well, based on what I saw in the past, based on what I'm seeing right now, I believe you will sort of use up your contract quantity earlier than expected. And that means reach out to your supplier in a position of strength. You still have some laptops left that you could order for newer hires, but seek the discussion to extend the contract, maybe get an even better price, rather than seeing at short notice, whoops, now I can't order any laptops anymore, contract is used up, what do I do now? That's not ideal. So intelligent enterprise and machine learning is a very big part of that. Chatbot is another, or robotic process automation as well. But here, of course, we're all about machine learning. And when talking about machine learning, I simplified a little bit, but I believe that it helps to break it down in 2 different areas. Whether the data that you want to use for machine learning, whether it's structured or unstructured. And if we look at unstructured data, photos, text, speech, for instance, then what we have here is we are basically deeply based on TensorFlow logic, where we have REST API web services that you can use out of the box that are already trained. You can pass information into it, you get a response back. You can customize these TensorFlow models to transfer learning, basically, or you can bring or even create your own TensorFlow model created from the ground up. So if you had scenarios where you want to use some TensorFlow, and maybe your corporate strategy is to use an SAP infrastructure, maybe you verified our cloud environment for you to be used in a productive environment, then this could be one way to bring that TensorFlow component model into the SAP world, serve it as REST APIs for us. And one of the simplifications is, I call it unstructured data here, really meaning for TensorFlow. Of course, it could also be very large, or potentially complex structured data. The lines are a little blurry now, but potentially oversimplified. But then moving to structured data, and that very often then would be data held in SAP systems. Maybe it's an ERP system, maybe it is S4, maybe it's your SAP Business Warehouse running on HANA, other content. And here we have 3 different approaches to carry out machine learning, and are structured in a way that ideally you would start on the top. I'm a big fan of automation, so if you need to carry out machine learning, we have a proprietary, well that's not open source, proprietary component to carry out automated predictive analytics, or AutoML you could call it. So we have that framework embedded inside the HANA system, our in-memory innovation platform. And while that component itself is proprietary from us, but we try to be very open to explain what happens in that AutoML world. We have very new Python and R interfaces that allow you to trigger that AutoML concept. So you can remain in RStudio, you can remain in your Python notebook, connect to a HANA system where the data is. We also have the machine learning algorithms. You can tell HANA in that case, well, use that data, use the algorithms that you have, train a model, tell me when you're done. So bringing algorithms to the data, rather the other way around, keep it central, keep the architecture lean, keep the models where the business data is, and thereby simplifying bringing those models into production. Because again, this is what it's all about. It doesn't help to have a fantastic model created locally on your own laptop. You have to bring it into business processes for these models to provide value. And I think here, that's one aspect where it can help to bring these models into a productive world, where you can still stay within your preferred open source environments. And related to that, I called it program predictions for developers or data scientists, I should say really, where in addition to that AutoML approach, we have, let's call it conventional algorithms that you would learn at university, that you'll be familiar with, whether it's a decision tree, whether it's a support vector machine. So if you prefer to use one of these algorithms, they're also embedded into that innovation platform in HANA, in memory available, where again, still out of Python and R, you can trigger these algorithms. And that's also very, very new with these algorithms in HANA. We've had for a number of years, and we keep expanding it. With every HANA release, we release new algorithms. But in the past, you had to use SQL scripting, coding, to trigger these algorithms. Maybe some of you have tried. And it works. You can make it work, but it's rather complicated. It can be very long SQL scripts, which is why I call it for developers. Because you have a very tight contract. Yes, you can hard code it, you can bring it to an application. And that's initially how it was meant to be used for OEM partners, so that other applications can benefit from it. But it didn't really fulfill the expectation of a data scientist. I mean, you don't want to go into SQL to create 50 lines of SQL syntax to train a predictive model. You have to keep track of which hyperparameters you are using, what is model quality. Not ideal. With the Python and R interfaces, much, much easier. And if you have to use totally different algorithms that we don't have in our systems, then we go completely freestyle scripting, where there are options to use your own algorithms, any libraries that you want to use, libraries that we don't have to validate, you can freely choose yourself. It just means, because of course data and the libraries, algorithms have to come together to train models, because these open source libraries won't be part of our platform. There, to some extent, you have to extract the data, train a model, or you can deploy the syntax in an SAP system. So basically, open for everything, whether it's AutoML, conventional algorithms in memory, or open source beyond that. And the product that you might be familiar with so far behind AutoML is called SAP Predictive Analytics. These other components are the HANA platform, and for the unstructured data, it's really the machine learning foundation. And I see people taking pictures, so just wait a second. But we'll also share the slides. So we'll get into better quality too. So these are the components you might know. And I mentioned, we are bringing these engines together. We'll be taking all these engines that I spoke about, and we are combining that in one central holistic platform where all the machine learning components get together, where you can deploy these components. That sort of new platform we call SAP Data Intelligence. And it is not just machine learning, it's also using our Data Hub platform. That's really the core. Data Hub, still fairly recent platform, I would say maybe 1.5, 2 years old, which is really all about data governance, data orchestration, it's about data transformations, and bringing that together. We have that platform where you can bring data together for creating that source of data that you need for your analysis anyhow, but then also the ability to train models, and very importantly, to bring these models into a productive process. And the productive process could mean it's a graphical process flow to create a pipeline that you can schedule to retrain the model or to apply the model at a certain interval, or it could provide you a REST API to service the trained model for inference out of other applications of intelligence. So SAP Data Intelligence, and this is the component that we plan to release later on this month, next 2 weeks. And before showing it live, maybe just 2 or 3 screenshots so that you've seen the most important screens from the machine learning point of view. There is a Jupyter Notebook integration into data intelligence, where inside the browser you can script. It is Jupyter, but it has a connection to data intelligence where you can centrally define connections that you want to use for you to use as a data scientist, maybe connecting to a HANA system or connecting to an Amazon bucket. And the beauty behind that here is that when you train models, everything happens in HANA, no data duplication. Even if you were imputing data, it does not change the raw data, it does not create a duplicate view or does not create a duplicate copy of the data. It is creating a logical view of the data that contains the changes that you decided to implement. And that makes it then very easy, it makes it easier than for IT process to take that information, put it into a productive process. It's very transparent. What data am I working with? How was the data transformed? What happened with it? Now I know what the data scientist has done, what you might have worked with, making it easier for IT to pick up at that point. And here we have a graphical pipeline where, I'm not sure whether you can see it, but different connectivity options here, where in this case I'm doing a demand forecasting for different time series, where I'm connecting to a HANA system that has history. That could be a VW system, it could be raw data. HANA might be aggregating the data on a monthly level. And then, in this case, I'm using R syntax to carry out my forecast. And behind this R operator, you're free to choose whatever R syntax you'd like to use, whatever R library you would like to use. You actually define your own Docker file, where you have full control over which libraries you want to install and to be available in this platform here. And behind data intelligence, we have a Kubernetes infrastructure, where you can also decide how many Docker containers do you want to be fired up. Is it sufficient to fire up one container, or just one time series after the other very independently? Or do you have thousands of time series to forecast? Maybe you want to fire up 10 containers in parallel, who work in parallel and thereby completing earlier. And for you, it's very simple to control how many containers should be brought up. There's a question?
Yes, now in this case you take the data out of HANA, of course.
Yes, exactly. So this is really the third option that we had on the earlier slide, where now we're taking data out of HANA. It is now in data intelligence. In data intelligence we do the prediction and the forecast, and then whatever was forecasted could be written back into HANA. Yes. Yeah. Another question? Yeah?
It's about flexibility. Is it either kind or or is it mixed together?
So
is it data only from HANA, or can you add other stuff?
This interface here can connect to virtually any source. You just connect it to HANA, what that's what we're using. You could here have an S3 bucket, you could have Hadoop, it could be a flat file. It's very, very open. And here, using the R operator, we have the same for Python, for Go, and for JavaScript. And you are free to pick and choose and combine as it makes sense. And you also have a control over saying, so how many of these operators should run in the same Docker container. So maybe this logically belongs together. It might be faster if it's the same container. Or if you're jumping between infrastructures for whatever reason, maybe different libraries that are needed that might not be compatible on the same image, you can separate wherever needed. And very similarly here, an example of the same interface, not for structured data, now for unstructured data, something that Daimler-Benz is doing, Mercedes. There's a use case where maybe you see a nice Mercedes-Benz on the street, you like the car, it looks nice, but what is the model? Maybe it's a new version, I wouldn't be able to tell what it is. And they use this interface to create a TensorFlow model, now running on data intelligence, that allows you to take a picture of the car that you've just seen. That picture goes into data intelligence. We can identify what is the car, what is the model, what is the color, what are the alloys, the felgen. And so it's very easy for you to know what you've seen. Maybe you like the car, maybe you want to talk to a dealer to get an idea about the quote. So that was another example for unstructured data. And with that, I'd like to go live into a session, and I really want to hurry up. And what I'd like to show live to you now is that Python wrapper, where I have some historic data in a HANA system that I'm connecting to right now. And here it's a table, it could be a view, no, whatever, doesn't quite matter, where I can see my history, and here the history, another use case that Mercedes-Benz is doing with us, that's the history of cars that were sold. I can see the model, I can see the year it was built, I can see the mileage, I can see the price it was sold at. Now I'd like to train a predictive model to estimate the price of further vehicles coming along. Maybe I want to sell a car, I want to buy a car, what is the fair price? And now you could pick and choose of any of the different machine learning engines that you'd seen earlier. But I'd like to do that now out of Jupyter. In this case, locally installed on my machine, but it could just be the same Jupyter notebook that you saw earlier in data intelligence, where I'd like to give a very brief example, and there's a lot more that I could show, but if you run out of time, just see us later at our booth if you'd like to watch it, we would like to go deeper. And here now, in this cell, so the first cell that I'm using that new component, the HANA ML library. This is what we call the HANA ML wrapper that we released for Python and for R, that allows you to create that direct connectivity from our Python to a HANA system, where we always push down the calculation logic to HANA. Keep the data where it is, use the power of the system. I'm connecting to HANA, where here I'm using the HANA user store, where I securely save my HANA username and password, you could also hard-code it. And I'm pointing to that table we just saw, the used car prices table. And if I'm connecting here, I created my data frame. And the important bit is it's not a pandas data frame. And if it was a pandas data frame, you could just call the object, and you would see its content. Here, because we on purpose don't extract the data, it's a pointer to the data that still remains in HANA. But you can extract some of the data if you want to do a preview. Maybe say, give me 5 rows, and still, same thing, still a pointer. Only when you explicitly call the collect method, now it's going to that table and it's only extracting these 5 rows of data that you asked for. So there might be millions of data, you don't want to move everything, just get a sneak preview, very quickly done, one line of code. And similarly now, there are many methods you can use on that object that always carry out that push down into the HANA system. And I might just use the aggregate here. Of course, it's documented. But let's say I want to find the most expensive car in my data set. So I'd like to have a max aggregation. I'd like to have that done on the price column. And I'd like to name the new column that comes back max price. Whatever. And here, same thing. It still does not move any data because, you know the correct now. Only now HANA has done the aggregation. It found there is a car that was priced at that value, and only that one value that HANA calculated is now brought back onto my client. And here, maybe to explain that value, could be data quality issue, of course, but it's actually data of cars that were offered for sale on eBay about 2.5 years ago. So it's not necessarily the price the car was sold at, but it's the price here the car was advertised as. So that's also the reason why we can show this data, it is publicly available. So maybe here very quickly you identify the data quality issue, or a funny guy who thought it's raised some interest and will make the car really expensive now on eBay. And this is very much sort of how it continues. You have a data set now, and it is really, I'll show you the very, very brief version. You want to understand the data that you have, that you're working with. Here, you can now drop missing values. You could also impute these, whether it's categorical or numerical, both is possible. But by dropping these null values, dropping NA, it sort of created a new view of the data. It did not delete any rows, because you might need the data for other purposes. Maybe it's these tables are used for other things. You can't change the underlying data. But here now, semantically, just calling the drop NA, what it actually did is it extended the select statement on the table that I'm working with to here now filter out the missing values. And we won't split the data here now in this very brief example, but of course you can split the data. You don't even have to physically separate the data one by one. You can do that logically. And once you have your train and test data sets, you can now start training a machine learning model. In this cell here, hopefully it is not too small. If it is, please come and see us later on, where I'm using the decision tree regression inside HANA on the data that still remains in HANA. We can give it some parameters that I like to use for the model, the features to consider for the model, and purely by calling here the fit method, it told HANA, well, actually go and do it. The same could be done in SQL syntax, but would require guessing 50, 60, 70 lines of code. So here, a much easier, more elegant way to get started. And the model has been trained, and to complete, now it can tell me a quality indicator. And you see how many other notebooks I have on the left-hand side? I didn't intend to show these in here, the time wouldn't be sufficient, but I think these other notebooks are a bit more realistic workflow for a data scientist to understand the data, what are the patterns, and maybe a scatter plot, a correlation matrix, impute a categorical variable, train a model, do some hyperparameter tuning. Once you have that model, save it to HANA, apply it on new data, so on and so forth. And once you have done all that, and you now apply the saved model, we can see that model in action. With that, I will complete, because I think we're really running out of time. But here we have two vehicles that are virtually identical. CLK produced in 2006. Only one difference. One car has driven 50,000 kilometers, the other has driven 150,000 kilometers. And now applying the model that I've trained, it is telling me there's a price difference of about 3,000 euros between these two cars. So having driven these 100,000 kilometers extra, reduced the car price by about 3,000 euros. With that, I'd like to complete my talk. Do you have any questions? Do we have time for questions?
Yeah, we have a couple of minutes, maybe one or two questions. Let's take this one first and then here.
Yeah, I would like to ask if you also provide this for teaching. So we have some environment that could show this to students, like a pre-arranged set of data, because I'm always short on presenting new data for business environment.
Yeah, we do. So everything I showed can be done in an environment that we provide free of charge. It's called SAP HANA Express, where HANA itself can be used free of charge, even running on a virtual machine on your laptop, I believe, or a Docker image. And once you have that, it contains a HANA mail wrapper. So you technically, everything you have could be used. And I'd be very happy to share the notebooks that I'm using here with you. If you want to bring that to your students, that'd be fantastic, because it's so new. I don't think we have any other content already publicly on the internet.
Yeah. Should I contact you then?
Yeah, if we just swap business cards, maybe.
This would be fine.
Yeah, got it. Sure.
Okay, thank you.
I have a couple of questions. Is it possible to install packages? And is it a security issue? And what kind of data type are the models that you save in HANA? What kind of data type is it?
Yeah. So when you save the model, it creates a table with a C block content, I believe, C block column type that contains the data. And once it is saved, it is a normal HANA table you can then use to load the model from to use forwards. There might be other questions. Yeah, there were different questions?
About R packages that you can install. Is it just possible to install whatever R packages, and is it a security issue?
Okay. That is always a challenge with open source, yeah. But what happens here now, you can install your own R packages in the graphical environment that we saw with the time series forecasting. And then, given the correct access rights, you can create your own Docker file.
Okay. Thank you very much, Andreas.
Thank
So maybe we have a booth downstairs. If there is more questions, please